Hi, in this video, we are going to take a look at using a large language model for classification. All right, so one of the many uses of large language models is that we can actually get supervised learning scores and classifications from them. So we can actually prompt a large language model to go through and give us an evaluation from like 0 to 1, 0 to 10, something like that. So this is potentially a supervised learning process. That one specifically would be for like regression. Now, we could also use supervised learning for classification, and this could be for like classifying topics. Now, a major advantage of large language models for the classification of topics is that we can perform topic analysis with user-defined topics. Now, we're not going to talk about that today because we're going to baby step into it. Um, what we're doing here is I have a target variable that indicates, was an email spam or was it ham? Was it legit or was it a spam email? And then what we're going to do, we're going to use a large language model to look at some text and decide if we have a spam or is it ham. All right, so why would we go this route? Okay, so there are tons and tons and tons of models for the purpose of classification. And really we can approach this as like a bag of words model also. Invoke some NLP, something like that. So there's plenty of tools to approach this. This is another tool in our tool belt. A major advantage of this approach of using a large language model for classification like this is that, you know what, I don't go through the feature selection process. I'm not going to fuss with it. I'm not going to bother with it. I'm going to take my text, I'm going to pass it to the large language model, and it's going to give me my output. All right, so this is just one feature, one aspect that I don't have to fuss with. Now, anytime I'm doing anything with text, I want to consider data prep. Always want to consider data prep for any project. Now here, what I'm doing is I'm taking some text and I'm passing it to a large language model. So there's some things I'm going to want to consider. So, correcting spelling, correcting grammar, removing repetitive white space, removing emojis, URLs, email addresses, non-ASCII characters, and non-printable characters are just some of the steps that I thought up when I sat down to create this video. Of course, there'll be others on there. Now, if you think about it for a moment, if my goal is to detect spam, well, misspellings will be an indication of spam. Poor grammar will be an indication of spam. Like URLs and email addresses, links and stuff like that would be indications of spam. So for this purpose, for this video, I'm not messing with any of this. I'm just running it through. Now, there's some major disadvantages for large language models to the point where, honestly, I would avoid them professionally if I could use other tools. So first and foremost, they take a long time to fine tune. The model I'm going to show you ran overnight on my computer. I have a decent, pretty powerful laptop, and it took a while for it to work. It took several hours. And the data set's it's less than 6,000 rows, so it's not a large data set to work with. Also, something that I've seen, and this has been in my professional work, is that we can get inconsistent results when I give the same prompts when I use Gen AI. Now, that's not, I haven't seen it for the classification, the supervised learning role yet, but if I'm getting inconsistent results with Gen AI, I should anticipate that I could potentially get inconsistent results off of the supervised learning approach. Honestly, I anticipate that they would probably be close to each other, but inconsistency is inconsistency. Also, large language models can generate hallucinations, bias, and toxic output. This is more of a concern for the Gen AI, but if it's a problem there with the model, we should always keep that in our minds as we're using the model for another purpose. Also, something about the hallucinations, the bias, and the toxic output is that this really this has put a lot of organizations in a cautious mode. Simultaneously, right now, it's July 2024, organizations are going are very, very, very interested in Gen AI to try and get around, problems, make, things more efficient, make it faster, make it cheaper, deliver, better support to their customers without having to put a lot of like, a heck of a lot of effort into it. But because of the hallucinations, bias, and toxic output, organizations are very scared of this. And we don't want inaccurate information, we don't want biased information, and we don't want to have like negative toxic output. So hallucinations, that's when a fact is stated that's incorrect. Biased is when there is some kind of bias that's going on. And so remember, whenever we're training a model, whatever my training data is, my model looks like my training data. So if they go through and when they train the baseline model, if they have bias in the text, which our society has bias in it, that bias is going to get pulled into the model. Now, toxic outputs are, like a remark like, oh, well, she never really performs well anyway. Like things that aren't implicitly biased, but are negative and disparaging. So like, for example, if we were talking about a coworker and the coworker dropped the ball on something, and, which, happens, it's going to happen. You could say something like, she dropped the ball. And that's a fact. That's not a toxic thing. But if you say she dropped the ball just like she always does, that always does is a toxic statement. And so these disparaging remarks, are just, are a risk of anytime we're using a Gen AI model. And so what ends up happening is that you're going to have a lot of oversight if you're working on a Gen AI model professionally. And this can result in the phenomenon of like too many chefs in the kitchen, and a lot of people are involved, a lot of competing priorities, and it can be hard to get things done because everybody kind of like wants things to go their way. And you get conflicting priorities. I absolutely hate that at work, by the way. So, that's something to be mindful of. And so, honestly, the time it takes and the fact that you've got so many people involved, I would personally shy away from using a Gen AI model if I could. But if for my project, it was required, that's the only way to do it. Or that's just what my stakeholders want, that's what I'm going to do. All right, so let's go ahead and load the data. So what we're going to do, we're going to go to UC Irvine, their machine learning database, and we're going to get their spam collection data sets. And so here I can use Python to get this pretty easily. You'll notice that in a couple spots I have raw for the cell instead of code, and what's going on there is that it takes a little bit of time. I can just run it, save it, switch the cell to raw. That way I can show you the code, but I don't have to, if I rerun the notebook, I don't have to go through the full process altogether. And so here's how I got it. And you'll notice that I saved it as a CSV. And we've got two labels. We have ham, which I've got coded as a 0, and spam is coded as a 1. So if it's a spam message, it's a 1. If it's legit, it's 0. And I'm making the assumption that the data set is 100% accurate for the modeling purpose. Okay, so let's just take a look at what's going on. So here I'm loading the data that I've already got saved. Now, something I did to make sure that my code ran is I reduced the data set just so I can get a feel for what's going on. When I had the full data set, cells were just taking a long time, and it was hard for me to make progress on this. So what I did, and you'll notice I've got commented out right now, is that I reduced it down to just 100 rows of data. All right, so that's not very much. So when I do my train, validation, and test splits, I've got approximately 33 for each of them. So my initial training data was only 33 observations. That's not very much, but my goal is not to build, at that point, to build the model. My goal is to create functioning code, go through, figure things out, go to the full set, and run the whole thing. Now, some things came up, still had to resolve some issues, but things went, much easier for me. All right, so here's my data set that we're interested in. So here's the message. And here's the, the label is if it's spam or legit. And so here, this is spam, while this one is considered legit. And if someone sent me this message, I would be like, no, I'm not reading this. You need to, spell out your words. But it's labeled as legit. So we're going to keep it that way. All right, so now I'm going to partition my data. All right, so for this one, what I'm going to do, I'm going to have train, validation, and test. Training data is the data that I'm going to fine tune the pre-established model on. The validation data we use for further tuning, and then test is my 100% hold out set. My test set is completely, totally, and utterly separate from the rest of the process. This way that I get an honest estimate of how my model will perform in the future. All right, so how I'm going to approach this is that I'm going to use random, random generation of these three levels. So approximately 1/3 is train, 1/3 is validation, 1/3 is test. All right, and then I'm going to set up my X and Y. Now, I've actually got potentially 4 different X and Ys. I've got the total data set, I've got training, validation, and test. All right, well, how I'm going to approach this is that I'm going to have the training data, and I'm going to have the entire data set. The training data here, the X train, Y train, is I'm going to have my data there. I'm going to tune my model. Now, when I go to evaluate my model's performance, I'm actually going to run everything on the entire data set and then use the partition column to identify which ones was in each partition, and then evaluate my statistics on training, validation, and test. Now, why do I do it on all 3? Well, okay, my test set, that's the one I'm going to use for my actual understanding what's going on. But what can happen is that I can overfit my model. Well, it's hard to spot an overfitting unless you use your training statistics. So if I see a large gap between training and test statistics, then that's an indication that I've overfit my model and there's a problem I need to back off. And so by getting all 3, I'll compare train to validation, I'll compare train to test. If I see a large gap either spot, that's an indication that I have overfit my model. All right, and so here I can just take a look at how much I've got. So we can see that they're pretty close to each other, not exactly the same. Training has slightly less data than the rest, but it's close enough. All right, now to make sure that I have an idea of what a good model is, of course, an exceptional performing model will be obvious, but it's a good idea to solve your problem using a well-known, well-understood, well-established model structure, just so that you have a benchmark to compare what's going on, so that you can understand, well, if I'm doing all this work, all this fuss, and all this, all these meetings with the oversight people, is it worth it? Is it worth all my time and effort when I could just go to random forest or stochastic gradient boosting or logistic regression, something like that? And so I'm going to build a logistic regression model as a benchmark to see what's going on. So here, what I'm going to do, I'm going to do a bag of words using term frequency, inverse document frequency after I tokenize the text. All right, so now here, just as a benchmark, since I'm not actually interested in logistic regression, I'm keeping everything on default settings. I didn't really do any data prep, minimum data prep to get the algorithm to run. Also, I'm leaving logistic regression on default parameters. In scikit-learn, default is to use ridge penalty. All right, so here I'm going to do my term frequency, inverse document frequency. And so here I've got, here's my training TF IDF vectorizer. And all right, so here, so this is to, notice I've got the fit on here. What this does is that if I pass a document in, it will convert that document to the proper format for term frequency, inverse document frequency. Now, something about this is that I'm giving it only the training data. I'm not giving it the full data set. So what's going to end up happening is that words that are in the training data, but not in the other ones, validation and test will automatically be 0. Also, a word that's in test or validation is not going to appear in my bag of words model whatsoever. And so this is a shortcoming of this approach. All right, so here, this is to fit. So this is to transform so this is the object that transforms text into term frequency, inverse document frequency. Here's the actual transformation going on the training, and here is the transformation on the full data set. Now I'm going to go through, and once again, I'm going to fit a logistic regression model using my training data. Now I'm going to go through and get the estimated probabilities that we have spam for each document. Now that's across the entire data set. So I'm going to run predict on the entire data set. And so here I'm using the oh shoot, I meant to do that. I'm going to need to fix that before I teach class. And so this as the code as we have on the screen right now will give us a probability of spam for each one. And so now I'm going to put it into my data frame so I can use it later. I'm really big on keeping everything nice and clean in your data frame. All right, so now let's go ahead and just take a look at what's going on so we can get our confusion matrix statistics off of there, our precision and our recall. We notice that recall is not as good as we would like, and correspondingly, the F1 score is getting pulled down when we have spam. All right, so now let's go ahead and actually kick off using our or start building our large language model. All right, so first and foremost, I'm going to take my data frame and I'm going to convert the data frame into the right format. So from data sets, I'm going to create it to the proper data set format, and I'm going to use the from pandas, it's a pandas data frame, to get things into the right format. And so then I do that for the full data set, I do it for the training, and then I didn't need to, but I went ahead and did it for validation and test. I could actually get rid of this. Now let's go ahead and train our model. So technically, we're not training the model, we're fine-tuning the model. So when we do large language models, almost 100% of the time, we're going to take a pre-established model and then improve it on our data set. We're not going to actually train the model, we're going to fine-tune. And so here, this is actually a functioning model. Potentially, I could just go and start using this directly, but it hasn't been built up for that, for my purpose. Since it hasn't been fine-tuned for my purpose, it's not going to perform as well. So let's go ahead and start tackling this. So first and foremost, I'm going to need to tokenize for the purpose of the large language model. And so I'm going to use the auto tokenizer to tokenize the text so that the large language model can interpret what it's looking at. All right. And so I'm going to say, hey, I want to use this model. And now we're going to, for the purpose of classification, I'm going to do auto model for sequence classification using exactly the same model. And my number of labels is 2. Now I'm going to go through, I'm going to tokenize my data. So here I had to define a function for this. I try not to define functions. I know that the Python community is like real big on defining classes and functions. I try to be a little bit more direct if I can, but to get this to run, I honestly couldn't see a reasonable way around defining a function. So I define a function. And the reason why I don't like to define functions is because that function disappears, going forward. It's not like you have it like stored in a module and a package to grab later. I feel like it is a mistake to use custom functions when you're teaching, because students aren't, they'll see that, they see that the function use, it makes everything all nice and clean, but students are already trying to wade through stuff. And if you make them bounce back and forth between spots in your code, it's just hard to figure out. If you could just do it directly, I feel like you should just do it directly. All right, so let's go ahead and apply my tokenizer function to the full data set and the training data set also. I could have just, I didn't need to do validation tests, but I went ahead and did it. Now here, got some job. So this is just a display error. It doesn't impact the performance at all. Now let's go ahead and fine tune the model though. This is the step that took a long time overnight, that I'm using the trainer function. Here's the model that I already created or already called. This is my training data set, and I'm using my validation data as my eval data set. And then once I fit the model, I went ahead and saved it. And so now I don't ever have to fine tune this again. And so if I'm going to rerun the notebook, I'm not going to rerun this cell. I'm just going to call the model. All right, so now let's go ahead and evaluate my fine-tuned model. I'm going to change this right here, right now. Fine-tuned model. All right, and so here now I'm gonna get everything into the right format to be able to pass it through, and we're going to be using softmax for this purpose. Now, softmax compared to instead of like regular, like more direct logit, which I will be using logit in a second, but softmax, my impression is that it tends to give stronger scores than like going like more directly to logit. Usually, like every time I've seen it, you'll get the same classification no matter what. But softmax will give you like maybe like a 0.9 when direct logit will give you 0.75. And so same classification, but it looks more extreme. It will give you the impression you have stronger results than you really have, is what I've seen on some of my projects. And so here, we're just going through, setting everything up the way it needs to be. Now I'm going to go through, and this is the step I'm going to use to actually declare is this spam or ham. I'm going to get an estimated probability that the message is spam, like this. All right, now I've tried to do this cell with list comprehension. List comprehension is like this. You notice I've got a list going, and inside my list I have a for loop. That's list comprehension. I like this. I prefer this over other techniques. I find it's nice and clean, and it's packaged nicely. For me, I don't have to do any work, don't have to do any iterations. It just execute, boom, for me. It's a little bit harder to read though. And so now, unfortunately, my kernel kept on dying every time I tried to use list comprehension on this step. And so this is not the way I typically would go, but it's all right. Another issue I had was that when I established this probability of the fine-tuned model, it wasn't storing the sufficient decimals on there. It was when I put it in there initially, I had none, and then the actual saved values in the data frame weren't of sufficient precision, and so hereby I then put in a -1 instead of a none, and still had problems because it wanted an integer value, and so then putting -1.0 solved that problem for me. All right, so what I'm going to do is I'm going to go through here. I've established an entire column of -1s, and I'm going to go down the list. And if I see a -1, I'm going to go ahead and get the estimated probability. And so why did I do this? Well, I was having trouble with the kernel of having it go. It kept on getting stuck. So you'll notice on each iteration, I saved my data frame. Now, this isn't the most efficient way to go, but really I should do it like every 10, every 100, something like that. I didn't have to do it every single time, but I didn't want to fuss with the code, so I just saved it every single time. And so this gives me a way of like, well, the kernel died. I've saved my results. I can just pick up where I left off very easily. All right, so now we've got from our logistic regression, this is the logistic regression classification, and here is the estimated probability from the large language model. And we can see here's the partition of train, validation, or test. And now let's look at the AUC, and you'll notice that I've got 0.82, 0.79, and 0.79 for my train, validation, and test statistics for AUC on the logistic regression, while for the large language model, I've got 0.99, 0.99, 0.99 for all three. So the large language model did a much better job. If I saw a significant gap between train and test or train and validation, that's an indication of overfitting. And I would pump the brakes. So here it's a little bit of a gap, but that's okay. In my opinion, this is close enough. This is very, very small of a gap here. Almost always, in practically all situations, your training statistics will be better than your validation and your test statistics. So expect to see a gap, but if it's big, you have a problem. Now, how big is big? It's a subjective call. All right, so let's go ahead and look at the ROC curve. So I made the mistake of doing predict instead of predict proba on the logistic regression curve. And so here, this is the cutoff this is going to correspond to the 0.5 cutoff of estimated probabilities. And so, this is not a terrible model. It could do better. I've seen models with, this AUC go into production. But so we've got a look at that. Now let's take a look at our large language model. I'm going to shrink this down just a touch. Now look at that. Look at that. That is beautiful. That is beautiful. This is I want to print this up and put it on my mom's refrigerator so that she's proud of me. This is a really strong performing model. I've got AUC that after rounded off is 0.99 for train validation and test. Now remember, there was a gap, there was a little bit of a difference, and we can see that difference here with the blue here for training. Then the validation is the orange. This is the one that it did the worst on, and then the green is the test. And so here we have our AUC, and we have our ROC curve very nicely presented. And so we have an idea of how our model will perform if we decide to choose different cutoffs for declaring spam or not spam. All right, well, that's all I've got for you. Life is short. Do math.